In 1600, William Gilbert's revolutionary treatise on the magnet disclosed that pounding hot iron induces magnetism in the metal. He also reported that a magnetized needle, when floated in water, not only pointed north, but also slanted down, towards the Earth. The needle seemed to be reaching for something. For Gilbert, this meant the Earth had a magnetic soul. He was right. The Earth itself is a giant magnet. Researchers today believe that magnetism comes from currents in the liquid metals in the Earth's core, but there are still as many questions as answers. We do know that magnets come in all sizes, as large as a world, as small as an atom.
Today we know that the origins of all magnetism are in the atom. And it comes from the way the world works. The way the world works is the atom consists of electrical charges. They have names, the electron and the nucleus. That's essentially the two parts of the atom. And the nucleus is tiny little small thing, so floating in the middle of a giant volume in which electrons whiz around. Now, if you have an electric charge that's moving, you create a magnetic field. But if these magnets are misaligned, so that here's a North Pole and a South Pole, and there's a North Pole and a South Pole, and they're all every which way, then the net effect is zero magnetism, and that's what most substances are. They have no magnetism.
But in some metals like iron, clumps of atoms line up and point their poles in the same direction. These clumps are called domains.
And suddenly you have an accumulation of all North Poles on one side, all South Poles on the other side, and you have a bar magnet.